All right, guys, hello. So today we're talking about radicals and rational exponents. If you remember, it's been a really long time since we talked about what rational and irrational is, but rational is a number that can be written as a fraction. So we're going to be having fraction exponents and talking about how it relates to radicals. And if you can remember, radicals are those root signs, not necessarily square root, but maybe cubed root or fourth root. So that's the kind of stuff we're going to be talking about. I'm going to go actually into a Pearson lesson to start talking about this. We're going to really ease into this. This week is going to be one that's kind of tough, and I'm actually just going to talk here for a second. Every year when kids come back to visit me who are now in ninth grade in Math 2 Enhanced, the thing that they say is so difficult, and it's right in the beginning of the year, is this. Math 2 Enhanced actually starts with rational exponents and everything we're doing this week and part of next week. So if you have been kind of lagging, not really doing the work, I really truly recommend that this is the week you kind of tune back in, because this is the stuff that's going to help you so much in the beginning of next year, because I know that they start the year with rational exponents. So anyways, we're going to kind of ease into it. Today's lesson won't be too bad, but it does get pretty difficult as the week progresses, okay? So I'm kind of going to just read to you guys what it has in Pearson right here, and then I'll do some examples. It says, what does 3 to the 1/2 power equal? So let's go through this lesson a little bit. So you can think of exponentiation as repeated multiplication. This you already know. 3 squared is 3 times 3. 3 cubed is 3 times 3 times 3, and so on. But what does 3 to the 1/2 mean? You cannot multiply 3 by itself 1/2 times. Since interpreting exponents as repeated multiplication does not work in this case, you have to define a new meaning for expressions like 3 to the 1/2 power. So basically they're saying, we got to figure this out somehow. Whatever the new definition is, you want to obey it. You want it to obey the same rules of exponents you know for integers, such as the power of a power property. That's the one you guys reviewed in the last video. So what they're saying is, let's try to get rid of that fraction exponent by multiplying it by itself or to the second power. When you do that using the power rule from yesterday, you have to multiply those two exponents, and what you end up with when you do 1/2 times 2 is 1. So the result is 3. Now, I know this might be confusing right now, so just give me a sec to get to the point, okay? Gotta scroll down. All right. So a number whose square is 3 is the square root of 3. In order to define raising a number to the 1/2 power in a way that makes sense, we're defining 3 to the 1/2 power to be the square root of 3. We're saying that those two things are equal to each other, and we proved it up here. You can define the meaning of other rational exponents in a similar way. If the nth root of a is a real number and m is an integer, then a to the 1/nth power equals the nth root of a, and a bunch of stuff right here that I'm not going to go too into yet. That's a lot of words. I want to talk to you guys about what this means and how we're going to apply it. So what that was saying, and I have it written out right here, a lot more sloppy than you saw it about in the last part of the video, but that's okay. So whenever you have a fraction as an exponent, so you'll always have a numerator and a denominator. We're just calling it m and n for these purposes, so that you can see where these go. You're going to be asked to convert that into a radical form, which would look like this, with the square root, not square root symbol always, sometimes cube root or sometimes fourth root. So basically the way that you do this is where the numerator, what the numerator is, that stays the exponent on the a, and then the denominator of that fraction is the root that you're being asked to find. So if that was a 2, you'd be asked to find the square root. If that was a 3, you'd be asked to find the cubed root. And they just rewrote it like this, pulling that M out. But this is really the way that you guys are going to be writing it when you do examples. So let me show you how this is going to apply to a problem that you're going to get. So let's say you got this as an example, number 1 here, and you're asked to write this in radical form. What you're going to be doing is just converting it so that it looks, right now it looks like this, and we want it to look like this. And we're going to use color coding right now till you guys kind of get the hang of this. This is going to be something that's going to help you with the actual lesson. This is really just a preview to the lesson, but I'm kind of making this its own lesson because it's something that we're going to really have to get used to before we dive into the more tricky problems. So using this same format, we know we're going to have that radical sign. We know based on this example that the base, it stays that big number. That's important, okay? The exponent that stays on the 2 is going to be the numerator. So this one right here, it was a 1. That's going to stay there. And obviously we know that we don't have to write the exponents 1, but I'm writing it just so that you guys can see where all these numbers are going. The n that was in the denominator turned into the root. So it was a 3 that's going here. Okay, so I'm going to rewrite this all in black without that exponent 1 since we don't really need that. And if I just gave you this, this would be asking what is the cubed root of 2? So that means what number times itself 3 times will give me 2. And it's not going to be a nice clean number, so you don't have to actually solve that. My question, if this were like a test question or something, or like you'll see on the practice, is just going to say to write this into, I'm losing my train of thought. Write this into radical form, and that's what that would look like. Okay, let's try another one. Okay, so what I'm actually going to do, I just decided, is to do examples from the worksheet that goes with today, because there are 4 sections, so I'm going to do 1 or maybe 2 problems from each section with you guys. So if you are planning on doing that practice worksheet, this would be a good time to print it out or get out a lined piece of paper to do your problems on. The first one I'm going to do is number 1 from the worksheet. Actually, change my mind. I know this is a video and I could edit it, but I don't really know how, so you guys get to see me erase. Sorry. I'm going to do number 2 because it's a little different than the one we just did. So this is number 2 from the worksheet that goes with today. It says 4 to the 4/3 power, and the directions say write the expression in radical form. So my goal right now is to go from this exponential form to radical form and have it look like this. Okay, I think color coding is smart until you get the hang of this, of what the numerator and denominator mean. So I'm going to actually rewrite this in those colors to start. So I'm going to always put my numerator in red and then my denominator in blue. And I'm just going to follow this picture to get my answer, and that's what I recommend you guys do until you really have this in your brains. So what this means, so I'm always going to start with my radical symbol, and I know that the big number underneath that is always going to be whatever the base was of that exponent. So that means the 4 goes there. According to what we learned from that book, from our book, is that the numerator stays the exponent, so that means this would stay 4. And then the denominator tells you which root it wants. That would be the cubed root. So let me rewrite this in black, just so that we can kind of see it all coming together like that. And that would be written in radical form. I think that's all I'm going to do from that section because it's pretty straightforward as long as you follow this. Just keep that in mind, that the numerator stays the exponent and then the denominator becomes the root that it's asking for. Keep in mind also that I erased the part that was here before, but the answer key on worksheets might look like this. And they'll pull that exponent to the outside like that. So you might see it written like that. It means the same exact thing. Something quick that I just want to add is that I want you guys to keep in mind that when you see a radical sign with no number here, it's implied that there is a 2 there and that it's asking for the square root of something. So if you ever have a denominator that is a 2, that's always going to be asking for the square root. So let me actually write that. Let's say you have, I'll just call it x, and the denominator is a 2. That means it's asking for the square root. And then the numerator, can be anything, and that's the number that's going to go on that x. I should write that here so that that's more clear. So I just wanted to throw that out there. The 2 is not written there. It's one of those invisible things that's implied. The next one that I'm going to do with y'all is number 7 from that worksheet. It's from the next section. Oops, that's going to kind of bother me. Oops, that's going to bother me even more. I know it would bother you guys too. So just for you, I'm going to erase it. And now I need a brush. I'm a struggle today, you guys. Okay, number 7 looks like this. So we would read this as square root of 10, and now that I talked to you about this little sidebar up here, you know that there is a 2 there that's implied, okay? The directions are going to say write the expression in exponential form. So we're going backwards. Now it's giving us the format like this. We want it to look like that. You just need to know where those numbers go. So I'm going to just totally break this down working backwards from like what you see in number 2. First, I'm going to put that 3 back on that 10. So that would look like this. And you know what? Just to kind of get you guys used to it, I'm going to put the 2 there even though it's not needed so you guys can remember. So I'm just rewriting the same thing. And now I just need to remember which one of these is my numerator and which one of those numbers is my denominator, because I know it's going to make a fraction. So I know 10 is going to be my base, and I'm going to go ahead and circle in to keep my color coding consistent here. That's where your numbers will go. So the red is on top, the 3 is on top of that fraction, and then the 2 is on the bottom. So this is kind of starting to get messy here, but that would be the answer. So this is in radical form, this is in exponential form. And you're going to see 6 problems that are like that. So just keep in mind if there's no number there, it is a 2. Most of the time in problems that are talking about rational exponents, you'll have a different number than 2. But yeah, you guys will have 5 more problems to practice in that section. All right, here's the next one from the worksheet. We're getting the problems that are a little bit more difficult. So there's 2 things that have changed here. Now I have a coefficient in the front, which is different. And then also we have a negative exponent. This is why I reviewed the exponent laws yesterday with you guys, because they are going to come in strong, especially in the next few days. So the first thing that we want to do, usually I say deal with the negative exponents at the end, but in a problem like this, you want to get rid of that negative sign very first thing. So that's what I'm going to do. I know the whole cross the line, change the sign thing, and this negative exponent is being applied to this whole piece right here. So in order to turn this negative exponent positive, I need to put this whole piece to the bottom. So that's what I'm going to do. I'm creating a fraction, 5x to the 5/4 power. Okay, that's step 1. Get rid of that negative exponent. Now that I did that, the directions, I think I forgot to tell you, but they say write the expression in radical form. Now I'm just going to slowly, using my color coding and all that jazz, I'm going to go through and figure out Is the 5 going to be my number that stays on my 5x, or is it going to be my root, and vice versa with the 4? So I'm going to keep my color coding. I know that the numerator is the one that stays, and the denominator is the one that is asking for that root. So I know this problem is asking for the 4th root. And let's see what that would look like when we write it. I still have a 1 on top, just hanging out by itself, kind of lonely. And I know that this 5 is going to stay where it's at. I know that that 4 is saying the 4th root, so I'm going to go ahead and plug that 4 in where it goes. I know my 5x goes underneath the radical sign. Now, something I want to point out is that if you have a coefficient, it is absolutely crucial that you write parentheses there. If you don't write parentheses and then you put your exponent, what that means is that the exponent's only applied to the x when actually it needs to be applied to the 5 also. So the parentheses are very important. They remind us that we have to distribute. This is one way that you can write your answer, and then the other way would be to just pull that 5 out, which is going to make this look kind of messy, but it would look like this. So I got the 1 on top still. I still have my 4 here. I still have my 5x underneath. And now the 5 goes out here. This is the way you'll see it on the answer key. But this is the same thing. So that would be the answer. Problems like this are definitely more tricky, so just take it one step at a time. Focus on the negative exponent first. If it has one, it won't always have a negative exponent. And then just slowly go from exponential form to radical form. Skipping right along to number 20. This is one that's asking me to write the expression in exponential form, very similar to that second section that I talked about, but now I have a coefficient. That's the only difference, and it really doesn't change things much for us. So I'm going to do this the same exact way as I did before. I'm going to go ahead and put that 4 next to the 6x, just because that's the way that I'm familiar with looking at them, which would look like this. Okay, and then I just need to remember that the number that's underneath is the numerator, the number on the outside is the denominator, and I just need to rewrite that as its fractional form. So the not fractional form, exponential form. The 6x is my base. And remember, because there is a coefficient, it's really important to write those parentheses. My exponent, as I said, my numerator is a 4, denominator is a 3. And just to remind you, if I didn't have those parentheses there, then I would be saying that this exponent only applies to the x, and that's not true. That exponent applies to the 6 as well. So that is how you would write this in exponential form. So I'm going to do a couple more problems from the very last section of the worksheet called Simplify. These ones are going to get us a little bit further than just going from one form to the other. A lot of times in a problem where it says simplify, you'll actually end up with just a number as an answer. Unless it has a variable in it, obviously, then you'll have a variable as well. So I'm going to do number 26 first with you guys. The first thing I notice is that my exponent's negative, and I want to fix that. So just like we did before, we're going to cross the line and change the sign, giving me 343 to the 4/3 as my denominator. Holy moly, that's so sloppy. Let me try to write better as I progress here. So I'm going to hop down here to the next line so I don't feel like I have to write so teeny tiny. I'm going to go ahead and change this to radical form. So I'm keeping the 1 on top. I know that I'm going to kind of go a little bit quicker here since we just practiced all those. My 3 becomes my root, and the 4 is the exponent here. All right, so to simplify this even further, we're definitely going to want a calculator, because to try to find 343 times itself 4 times and then find the cubed root of that is going to be really, really difficult to do in our heads. what I'm going to be using right now, and I'm going to write it down here at the bottom so that you guys can use it as well, is a Desmos calculator. It's not one that I've gotten to talk to you guys about in class ever, because we haven't really done problems like this ever, and we haven't really needed a calculator like that. So it's desmos.com/scientific. That's where you would want to go. And I'm going to show you how to type this whole bottom part. Let me circle. I'm going to type this whole bottom part into that calculator to see what my denominator actually is, because I do know my numerator in this answer will be 1, and I just want to know what's that denominator going to be. So let me pull up that calculator and show you how to type it in. So this is what it'll look like. What you're going to do is, so in the long run, I'm going to need to use this button right here because I want to tell it what root to use. If I press this button, that's going to be a square root. So I am going to use I'm going to need the cubed root. So that's what you would put there. And then underneath the radical sign, this is where you have to be really, really specific. I'm going to go ahead and I'm going to use parentheses because I love me some parentheses. I'm going to put 343, close parentheses, and I'm going to put that to the 4th power. So you have to learn this calculator and learn to type something in just like that. You want it to look just like it did when you wrote it. And if something's even the slightest bit off, it's going to give you the wrong answer. But you can see from this, the answer is 2,401. So now I can go back and type, and not type, but write that in. 2,000, what did I say? 401. So this would be the answer. So imagine, a couple days ago, if I just said, hey guys, what is 343 to the negative 4/3 power? That seems very overwhelming, and you know what? It probably does still seem kind of overwhelming, but you're just going to take it step by step, go really slow, use these examples to help you. I have fixing negatives first, slowly go from exponential to radical form, and then use a calculator, okay? The problems are tough, I'm not going to lie. We're getting into stuff that's really challenging, so do your best. I'm here if you need me, and I think that's it for this lesson. Go work on those problems that we didn't get to do together. Oh, one last thing. I want to remind you guys, because this will really come in handy. Anytime you have something to the 1/2 power, 1/2 in radical form is square root, right? Because this number on top stays with the x underneath, and then the 2 is on the outside, but we don't have to write it. This is going to come in handy. So anytime you see something to the 1/2 power, they're asking you for the square root of that thing. So just keep that in mind too. Okay, good luck, and let me know if you need anything. Bye, guys.